grade 4s. I hope that you had an absolutely wonderful weekend. Hope you had the opportunity to get outside and enjoy some of that sun yesterday. And heck, maybe you get outside and enjoy some of that rain, lightning, and hail on Saturday. I know that I got a good soaking when I was walking on Saturday. Sometimes it's just refreshing to get into that rain. Anyways, let's talk about math today. Today, we are going to be looking at a new technique called multiplication by breaking apart. Today, we're going to start with smaller numbers. We're going to do some double digit by single digit and some single digit by single digit. But tomorrow, we're going to get into double digit by double digit. So today, we are going to lay down the foundation so that you can get a firm grasp on this technique for multiplication. Now remember, maybe this is the technique for you, maybe this isn't the technique for you. Mathematics, it's like carrying around a big toolbox at all times. And some of the tools, they just don't make much sense to, but they make a lot of sense to other people. But it's important to know what the tools are. So as we're putting a new tool in your toolbox, I want you to think about, is this one that works for you, or is this one that doesn't work for you? In math, there are many ways to get to the correct answer. It's all about finding the method that works best for you. Before we get to multiplication by breaking apart, let's do some review from yesterday's class. Last class, we were working on using the standard algorithm to multiply double-digit number by double-digit numbers. Let's get into it. So we have 329 times 135. Now, I've done the bottom row color-coded, just so it can help make a bit more sense. So we're going to start off with the ones column first. And the ones column is in orange. So everything in orange is going to be what happens when we multiply 329 by 5, the ones column, okay? So 5 times 9, that is 45. I got to put a 5 there, and I got to carry the 4 up over here. The reason I got to carry the 4 up over here is I can't write it down there because I haven't multiplied the tens column yet. So I need to make sure that this 10 is added to this 10. The tens columns go with the tens columns, the hundreds go with the hundreds, and so on. So now that I've carried over the tens, the 4 from 9 times 5, 45, I can now do 5 times 2. 5 times 2 is 10. But now I need to add what I carried over from the ones column. 5 times 2 is 10, plus 4 is 14. So I can put the 4 there, and now I need to carry over the 1. 1 and 4 equal 14. All right, next off, let's do 5 times 3. We start from the right, and we work our way all the way to the left until there's no numbers left. 5 times 3 is 15, plus 1 is 16. Seeing we have no other numbers to go, there's nothing in the thousands column right here, I can just write 16 down right here. Yeah. Next off, we're going to work on 3 times 329. But if we're looking at place value properly, and we are, then we know that this number here actually isn't 3. If we were to break it down into expanded form, 135 would become 100 plus 30 plus 5. Now, if we take a closer look at the 30, you'll notice that there is 1 0 there. Because there's a 0 there, when I start multiplying, I need to have a 0 at the beginning of my answer to represent it, okay? This isn't a 3, this is in fact 30 according to expanded form and according to what it is mathematically. So to represent this 0 and to show that this is 30, I need to drop the bomb. So what I do is I just put a 0 there. That 0 is the 0 right there. And it's going to make everything else now true when we multiply through. Super important, you drop the bomb, okay? So 30 times 9, but seeing we already dropped the bomb, we can just say 3 times 9 is 27. Now I need to carry over the 2. I'm going to put the 2 up here. Now remember, the old colors, we don't need to worry about. That was from the ones column. They no longer need to be there. If you're doing this on paper, you can simply just erase them and pretend they're not there. Once you've added them in, you can just erase them. The only number that we care about right now is the ones from the tens column. 3 times 9 is 27. Now I need to do 3 times 2. Well, 3 times 2 is 6. Plus 2 is 8. Nothing to carry over here. 3 times 3 is 9. Now we need to do the ones column. The hundreds column. Now, here we are. This is a 1 right here, but it's in the hundreds column. When we look at expanded form, 135 is 100 plus 30 plus 5. If we look at the 100, there's 1 0, 2 0. We have 2 zeros that we need to account for. If for the tens column we dropped 1 bomb, for the hundreds column we need to drop 2 bombs because there's 2 zeros there. Let's do that right now. Now that I've dropped my 2 bombs, I can begin multiplying. 1 times 9, again, we're starting with the numbers on the right. So 1 times the number on the right, then we move over, and then we move over. We got to multiply all of them. 1 times 9 is 9. 1 times 2 is 2. And 1 times 3 is 3. Now that I have all of the products here, I have the product of 329 by 5, or 329 times 5, the product of 329 times 30, right there, or the product of 329 and 100. So 329 times 100 is 32,900. 329 times 30 is 9,870. And 329 times 5 is 1,645. And here's the cool thing. If you look at it, what we just did right there, that is actually today's lesson, breaking apart. But we're going to do it in different steps. Back to the standard algorithm. So now that we have all our products, we need to find the sum. So we need to add up all of this. We need to add up the totals of these to find out what 329 times 135 is. So let's do that. We always start with addition at the right and move our way to the left. 5 times 0 is 5. 4 times 7 times, 5 plus 0 is 5. 4 plus 7 plus 0 is 11. And I carry over the 1. 1 plus 6 is 7. Plus 8 is 15. Plus 9 is 24. Carry over the 2. 2 plus 1 is 3. Plus 9 is 12. Plus 2 is 14. And carry over the 1. 1 plus 3 is 4. Therefore, 329 times 135 equals 44,415. Super important, when you're doing the standard algorithm, we start from the right and we work our way to the left. 5 multiplied by 9, 5 multiplied by 3, 5 multiplied by 3. Then we go on to the next one, the tens column. First we got to drop the bomb. 3 times 9, 3 times 2, 3 times 3. Now we move to the hundreds column. Drop 2 bombs. 1 times 9, 1 times 2, 1 times 3. Now we add up all of these products to find our sum, and that is our answer. That is multiplication using the standard algorithm. All right, now let's get into something a little different called multiplication by breaking up. Let's take a look, example, at, say, 9 times 5. Okay? So we know that 9 times 5 equals 45. And we can figure that out just by skip counting or by memorizing. But there's another way. We could break it up into smaller, more easier to understand segments. So let's break up the 9. What are ways that we could break up the 9 into smaller amounts? Well, we could do 5 and 4. Why did we choose that? Because 5 plus 4 equals 9. So all we're choosing to do is get the 9 and break it up into smaller amounts. This is going to make a lot more sense tomorrow when we start looking at bigger numbers, Kat. So 9 broken up into smaller amounts is a 5 and a 4. So what that means now is we have 5 times, well, are you here? 5 plus 4 times 5. When I look at this, 4 plus 5 equals 9. Now, in math, whenever you have brackets, you always solve what's inside the brackets first. As you get older, you're going to learn about something called BEDMAS. And BEDMAS is the order of operations. That's the order of things you need to solve in math. It's an acronym. The B stands for brackets. The E is exponents. And then we have division and multiplication. And last, we have addition and subtraction. BEDMAS. So we need to solve what's inside the brackets first. 5 times 5 is 25, plus 4 times 5 is 20. 25 plus 20 is 45. 25 plus 20 is 45. Oh, look at that. 9 times 5 is 45. They both equal the same thing. As you can see, multiplication by breaking up gives you the exact same answers. Let's take a look at another example. All right, now let's take a look at another example. Now, personally, I hate multiplying anything by 7. I find it so difficult. So we are going to show how to multiply by 7 using the breaking apart method. Let's look at 7 times 6. Now the 7 we can break up into smaller pieces. We want to break it up into smaller pieces to make it a touch more manageable. So we can break up 7 into a 5 and a 2. Why a 5 and a 2? Because 5 plus 2 equals 7. All we've done is broken this up into smaller pieces. It's still the same thing, still representing the same thing, but we've found a way to make it a little bit easier for us to solve. So let's put it now into our multiplication. So the first part is 5, and it's got to be multiplied by 6. So I put times 6 plus, the next part was 2 times 6. Now, let's look at why we have that. So the 7 we've broken up into 2 pieces, the 5 and the 2. Well, there's the 5 and there's the 2. But we also need to multiply this and this by 6. So there's the 6 there and there's the 6 there. This is still representing 7 times 6 because 5 plus 2 is 7 times 6. So this is the exact same thing. If I was to make this as an equation showing it as a balance, 7 times 6, this would in fact hold true. 7 times 6 is equal to 5 times 6 plus 2 times 6. This is true. 7 times 6 is equal to 5 times 6 plus 2 times 6. If I was to put this on one of the old school scales, they would both be equal to each other. It would be level. So now that we know this, we know that the breaking apart does work. So let's solve for it when breaking it apart. 5 times 6 is 30 plus 2 times 6 is 12. Add these together. That equals 42. 7 times 6 equals 42. We can solve it by memorizing 7 times 6, or we can solve it by breaking it apart into smaller pieces. 8 times 4. Okay? So the 8 is the one that we are going to break apart. Now, we could break this apart into many different things. Let's just go through the list of all the different things that it could be. It could be 1 plus 7, 2 plus 6, 3 plus 5, 4 plus 4, or we can go in the opposite direction of 5 plus 3, 6 plus 2, 7 plus 1, because addition is commutative. It's the same going forward as backwards. So what we want to do is when we break this 8 up, we want to choose the ones that make most sense to us. Now me, I find 5s and 10s are always the ones that make most sense to me. So I'm going to do 3 and a 5, okay? So 8 broken up is a 3 and a 5, which would mean then we have 3 times 4 plus 5 times 4. 3 times 4 is 12, plus 5 times 4, 20. 12 plus 20 is 32. Pretty nifty. I know, because I've memorized my times tables, that 8 times 4 is 32. So the breaking apart method works. Well, what would happen if we use different numbers? Let's say 2 and 6, okay? Instead of doing 8 times 4, let's do 2 and 6. So that would give me 2 times 4 plus 6 times 4. 2 times 4 is 8, plus 6 times 4 is 24. 8 plus 24 is 32. Look at that. They all equal the same. 32, 32, 32. They all equal the same. So we know that multiplication through breaking it up is going to give you the exact same answer. Sometimes this can make your life a bit easier. So this just might be a really good strategy for you to use. All right. So now I told you we'd get into something a little bit more difficult. Let's look at, let's say, 47 times 5. Now, we can actually break this up. This can be broken up. And the easiest way to break it up is going to be into expanded form. Okay? We're learning the breaking apart method with the simpler, smaller ones today, so that when we have to do double digit by double digit, it's going to be a lot easier. So if we want to break this up using expanded form, what this would equal would be 40 plus 7. 47 in expanded form is 40 plus 7. So now, instead of doing it the standard algorithm this way, we're going to do it a little bit different. We've broken it up into 40 and 7, so our first part is going to be 40 times 5 plus 7 times 5. Now, we've talked about in class before that anytime we see a 0, like a 10, well, we could just add the first two numbers, these ones, and then just add the 0 to the end of it. It's a little trick. So 4 times 5 is 20, plus the 0 is 200. 40 times 5 is 200. So let's look at that real quickly on the side here. 40 times 5 equals 200. 4 times 5 equals 20. The difference between our answers is a 0 here and a 0 here. So we can just add that 0 on, okay? We can just do in our head 4 times 5 and then add a 0 to the end. Easy peasy. 40 times 5 equals 200, and 7 times 5 equals 35. 200 plus 35 equals 235. Now let's see if this is correct using the standard algorithm. 5 times 7 is 35. Carry over the 3. 5 times 4 is 20 plus 3, 23. As I've said before, with math, the paths are many, the truth's but one. This truth is 235, and we could show you many different ways to multiply 47 by 5 and come up with 235 every time. It's all about finding the technique that works best for you. All right, let's delete this and let's do another one. All right, this one, let's do 29 times by, let's say, 6. 29 times 6. Let's do it using the standard algorithm first. 6 times 9 is 54. Carry over the 5. 6 times 2 is 12, plus 5 is 17. So we know that our next method, it has to equal 174, or else it doesn't work. Let's see if it holds true. How could I break up 29 using expanded form? Well, that would become 20 plus 9. There's 9 in the ones columns and 2 in the tens column. 29 in expanded form is 20 plus 9. That means that the equation we're going to get is going to be 20 times 6 plus 9 times 6. Our 20 and our 9. So we still have 29 times 6. We've just written it out a little bit differently. The first part we're going to solve is 20 times 6. Now, as I mentioned before, if you don't know how to do that in your head, you can use the little shortcut. 6 times 2, or 2 times 6, is equal to 12. There's a 0 here, so we add a 0. So 20 times 6 is 120. Again, how did I find that out? 2 times 6, I know, is equal to 12. That's one I can do in my brain. Can't do 20 times 6. But I do know that if I just add a 0, because there's 1 0 here, I can add a 0 to the end, equals 120. Let's just say it was 200 times 6. It would be the same thing. 12 and add 2 zeros. 2 zeros. Zeros are magic in math. They're really easy once you figure out the pattern. All right, back to it. 20 times 6 is equal to 120. Plus 9 times 6 is 54. I add these two together, and I'm going to get 174. Look at that. They're the same. Let's do one more question. Alrighty. This one, let's make it 99 times, let's see, 7. Let's make this one super duper difficult, okay? So, like last time, we're going to solve it using the standard algorithm first. Working our way right to left. 7 times 9 is 63. Carry over the 6. 7 times 9, it's still 63. Plus 6, 69. 99 times 7, 693. Right, now let's look at when we break it apart. Well, how can I break apart 99? I can use expanded form. 99 in expanded form is, how many are in the tens columns? There's 9, that's 90. Plus, in the ones column, 9. 99 in expanded form is 90 plus 9. Now I need to put that into our multiplication. I need to multiply both of these by 7. So that was our question. 99 times 7. So let's write that out. 90 times 7 plus 9 times 7. First one, 90 times 7 is 630. How did I find that out? Let's go back down here again. 9 times 7 equals 63. 90 times 7, because they're the exact same except I have an extra 0 here, all I got to do is add an extra 0 there. There's my 0. There's my 0. That's my little 0 shortcut. Do not forget it. It is super helpful. 90 times 7 is 630, plus 9 times 7 is 63. I need to add both of these together, and look what I get. 630 plus 63 is 693. It's the same answer. So we can break numbers up in order to make them easier to solve. Come tomorrow, this is going to make a lot more sense, and you will be grateful for learning a new technique. All right, everyone, have a great day, and I look forward to doing some more math with you tomorrow.